So guys, let's begin our discussion over the JEE Main pattern exercises for probability. The first question says that three numbers are chosen from 1 to 30 and the probability that they are not consecutive is what? So from 1 to 30, in how many ways can you choose three numbers? Three numbers can be chosen out of 1 to 30 in 30C3 ways. This is the total number of elementary events. This is the total number of elementary events. Out of available 30 numbers, 3 numbers can be chosen in 30C3 ways, right? What is the probability that they are not consecutive? So how can you basically start approaching it is, from 1 to 30, you are choosing 3 numbers. In how many ways can they come out to be consecutive? You can have 1, second as 2, third as 3. This pairing you can have, or 2, 3, 4 consecutive. 3, 4, 5, and in the end you can have 28, 29, 30. These are all the possibilities in which 3 numbers chosen can be consecutive. Nothing more than that. It can start with 1 or 2, 3 and so on till 28. So basically there are 28 favorable ways out of 30C3 total ways. 28 favorable ways for numbers, the 3 chosen numbers to come out to be consecutive. So if I say what is the probability of 3 numbers chosen being consecutive, very clearly it is 28 by 30C3, which is 1 by 145. But the question is to find the probability that they are not consecutive. So the probability of happening of an event is this. So the probability of not happening that event, probability of not happening of that event, that means probability of 3 numbers chosen being not consecutive will be 1 minus probability of happening of that event, which is this. And this gives you 144 by 145 as your actual answer. So your answer is 144 by 145. So first of all, I found out the probability that the 3 numbers chosen are consecutive, but I wanted the probability of them being not consecutive. So from 1 I subtracted the happening of that event of coming out of consecutive 3 numbers, and then I got the probability of 3 numbers which are not consecutive. Just by using the logic that probability of happening of an event plus probability of not happening of the same event is equal to 1. Moving to the next question we have, again 3 numbers are selected at random from this set which is having 10 numbers in all, from 1 to 10. The probability that the product of the 2 numbers is equal to the third. Now over here it's not talking about arrangement, it's just talking about selections. So from 1 to 10 you can choose again 3 numbers in 10C3 ways. This is the total number of elementary events. What are the favorable ones? Favorable ones are those 3 numbers such that the sum of the product of any 2 is equal to the third. Okay, so just think about all the ways in which product of 2 can be equal to the third. You need to choose such 3 numbers. So you can choose a 2, 3, 6. In this case, product of 2 is equal to the third. Either 3 into 2 is 6 you can say, 2 into 3 is 6 you can say. Now you cannot take 3, 2, 6 as another combination because I am not interested in arrangement, I am just interested in selection. Then after that you can say 2, 4, 8. Again don't consider 4, 2, 8 as another type of a selection. No, that is not another favorable way. After this you have what? 2, 5, 10. So there are just 3 ways in which 3 numbers can be chosen out of the available numbers from 1 to 10 such that the product of 2 is equal to the third, and therefore I am having 3 favorable ways. And so the probability is 3 by 10C3, which is 1 by 40, and that is your answer. Easy enough? Next question says a 2 cross 2 square matrix is written down at random using the numbers 1 and minus 1. So only by using these numbers is a 2 cross 2 square matrix written down, what is the probability that the matrix is non-singular? Okay. So first of all, in how many ways can you form a 2 cross 2 matrix with the entries 1 and minus 1? In a 2 cross 2 matrix, there are 4 entries that you need. This place can be filled in 2 ways, 1 or minus 1. This has 2 possibilities, this has 2 possibilities, this has 2 possibilities. So this can be filled in 2 ways. This work can be done in 2 ways, this work can be done in 2 ways, this 2 ways, this 2 ways. So all 4 works, that means the filling of all the 4 places can be done in 2 into 2 into 2 into 2, that is 2 to the power 4 ways. This is the total number of ways in which a 2 cross 2 matrix can be formed with the help of the two numbers 1 and minus 1. Out of all these matrices, which ones are non-singular? Which ones are non-singular? That means the determinant is not equal to 0. It's very simple to understand that if you take minus 1, 1, 1, if you take say 1, 1, minus 1, minus 1, minus 1, minus 1, 1, 1, 1, 1, minus 1, minus 1, 1, 1, 1, 1, minus 1, minus 1, minus 1, minus 1, okay, minus 1, minus 1, 1, 1, and minus 1, minus 1, 1, 1. These are the 8 2 cross 2 square matrices with entries 1 and minus 1, which are non-singular, and therefore out of the total 2 to the power 4 2 cross 2 matrices with entries 1 and minus 1, only 8 are those 2 cross 2 matrices with entries 1 and minus 1 which are non-singular. This number is 16 and your answer is 8 by 16, which is 1 by 2. Clear? And therefore 1 by 2 happens to be the correct option. Moving on to the next question, we have what is the probability for S's to come consecutively in the word Mississippi? Okay. Let us talk about this now. So Mississippi word, if you can very easily see, has 11 letters, out of which 4 S's are there, 4 I's are there and 2 P's are there. In how many ways can 4 S's come consecutively when you arrange the letters of the word Mississippi? So total arrangements can be how many? Total number of ways in which all these letters of the word Mississippi can be arranged in 11 places is 11 factorial. Now there are 4 S's, 4 P's, no 4 I's and 2 P's. These are the total number of ways in which all the letters of the word Mississippi can be arranged in 11 possible places. Out of this I am saying S's should come consecutively. So what I now do is I consider all the 4 S's to be one single word. I consider all the S's, all 4 S's to be one single letter. Now I am left with how many letters? 1, 2, 3, 4, 5, 6, 7 and all 4 S's are 8. That's one letter. So there are 8 letters now. Now there are 8 letters, 4 S's are one letter. This is just one single letter because they always have to go together. Wherever they are going, they are going to go together. Fine. So all the S's together are combining to becoming one letter single. Beyond that, in these 8 letters, in which one of the letters is all 4 S's, I have 2 P's and 4 I's. Now I need to arrange these 8 letters in 8 places, right? And I have 2 P's and 4 I's with me. I cannot say now that there are 4 S's because all 4 S's are now one single letter. So my favorable number of arrangements will be what? Favorable will be 8 factorial because there are 8 letters which I need to arrange in 8 places, but in that there are 2 P's and 4 I's. So these are the favorable ways and therefore probability becomes what? 8 factorial upon 2 factorial into 4 factorial divided by 11 factorial upon this or multiplied by 4 factorial into 4 factorial into 2 factorial upon 11 factorial. This gets cancelled, this gets cancelled. This is what you're left with and your answer eventually comes out to be 4 by 165. Clear? So that's how beautifully this question is dealt with. Now, next question says there are 2 non-negative integers x and y which are chosen at random with replacement, the probability that x square plus y square is divisible by 10. So when x and y are chosen, x, when you divide by 10, you get 10x1 plus a1. This is the quotient, this is the remainder. What is the status of the remainder? A1 is greater than or equal to 0 and strictly less than 10, which is the divisor, or less than equal to 9. I can say anything you can say. Similarly, y, when you divide by 10, you get a quotient and you get a remainder, where the remainder is greater than equal to 0 and strictly less than 10 or less than equal to 9. So when I talk about x square plus y square, it is actually 10x1 plus a1 square plus 10y1 plus b1 square. Right? This becomes 10 square into x1 square plus 10 square into y1 square. So 10 square comes out common, x1 square plus y1 square plus a1 square plus b1 square plus 2 into 10x1 into a1, so 20 into x1 a1, and from here 20 into y1 b1, so 20 into x1 a1 plus y1 b1. Now understand, I am wanting x square plus y square to be divisible by 10. X square plus y square is this. This term is divisible by 10. It's 20 times something or 10 into 2 times something. This term is divisible by 10. Only if this term will be divisible by 10 will x square plus y square be divisible by 10, right? So, what is the probability that a1 square plus b1 square is divisible by 10? Then I can talk about that probability being the same probability of x square plus y square being divisible by 10. So, now the motive has changed. Now our motive has shifted to what is the probability that a1 square plus b1 square is divisible by 10. Now understand, a1 has 10 options. B1 has again 10 options. So A1 square plus B1 square can be written in how many ways? Total number of ways in which A1 square plus B1 square can be written is 10 into 10, that is 100 ways. Out of those 100 ways of A1 square plus B1 square, what are the possible values of A1 and B1 for which A1 square plus B1 square is actually divisible by 10? Those are my favorable ones. See, A1 can take value from 0 to 9, B1 can take value from 0 to 9. So, A1 square and B1 square, both of them can take 100. Both these can be filled in 100 ways. So, A1 square plus B1 square can be formed in 100 ways. Out of those 100, which are the favorable? 0, 0, 1, 3, 1, 7, 2, 4, 2, 6, 3, 1, 3, 9, 4, 2, 4, 8, 5, 5, 6, 8, 7, 1, 7, 9, 8, 4, 8, 6, 9, 3 and 9, 7. Why? Because for example, if A1 is 1 and B1 is 3, then A1 square plus B1 square is what? 1 plus 9, that is 10 divisible by 10. If A1 is 1, B1 is 7. 7 into 7 or 7 square is 49. 49 plus 1 is 50 divisible by 10. So these are all the possible values of A1 and B1 ranging from 0 to 9 such that A1 square plus B1 square is divisible by 10. So out of the 100 values of A1 square plus B1 square, these are the values which are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right? So how many you have? 0, 0, 1, 3, 1, 7, 2, 4, 2, 6, 3, 1, 3, 9, 4, 2, 4, 8, 5, 5, 6, 8, 7, 1, 7, 9, 8, 4, 8, 6, 9, 3, 9, 7. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. These are all the ways in which you can basically write A1 square plus B1 square being divisible by what? 10. Clear? So therefore your probability becomes the total number of favorable events upon total number of elementary events, and that is going to give you the answer. So quickly note this down, understand this concept, and we are going to go ahead with the next question. Yes, so these are all the ways. In fact, you can also incorporate 6 too, because this is 36 and this is 4. I mean 6 square is 36, 2 square is 4. That makes it 40, and which is divisible by 10. So over here you can very easily see there are 18 favorable ways, and therefore probability becomes 18 by 100, that is 9 by 50, and therefore your answer turns out to be option number B. Moving ahead with the next question, what is it that we have? Let's see. A die is thrown, let A be the event that the number obtained is greater than 3. Let B be the event that the number obtained is less than 5. Then what is the probability of A union B? Let's see. Probability of A union B, if you remember the formula, that is what? Pretty easy. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Probability of A means what? Probability of A means, what is the probability that the number obtained is greater than 3? So when a die is thrown, sample space is 1, 2, 3, 4, 5, 6. Greater than 3 are 3 numbers, 4, 5 and 6. So favorable elementary events are 4, 5 and 6. Total are 6. 1, 2, 3, 4, 5, 6. So your probability becomes 3 upon 6, which is 1 upon 2. Probability of B means what? What is the probability that the number obtained on the die is less than 5? There are 4 numbers less than 5, so 4 upon 6. What is probability of A intersection B? That means A is also taking place, B is also taking place. When you are throwing the die, what is the probability that the number obtained is greater than 3 and less than 5? There is only one number which is greater than 3 as well as less than 5. What is that number? 4. So probability of number being greater than 3 also and less than 5 also is same as probability of number 4 occurring. So what is the probability of getting 4 as an outcome? 1 by 6. Therefore probability of A union B becomes probability of A plus probability of B minus probability of A intersection B. Right? This becomes what? 3 plus 4 minus 1, which is 6 upon 6, which is 1, and therefore probability is nothing but 1. Fine? Moving to the next question, we have, if A and B are two given events, then probability of A intersection B satisfies what? Let's see. Probability of A plus probability of B minus 1, or this or this or this. Okay, see, probability of any event you know is less than equal to 1 and greater than equal to 0. So minus of probability of A union B, because A union B is an event, will be greater than equal to minus 1. Now this is an indirect way of obtaining probability of A intersection B, because directly I do not have anything related to probability of A intersection B. Now when I add probability of A plus probability of B, they are also non-negative terms, greater than equal to 0, minus probability of A union B. Inequality doesn't change. Again I am adding on both sides. This is what you get. Now what is this? If probability of A union B is probability of A plus probability of B minus probability of A intersection B, then probability of A intersection B is probability of A plus probability of B minus probability of A union B. This is nothing but probability of A intersection B, and this is equal to the right hand side. If this term is greater than or equal to, that means it can never be less than this quantity. A intersection B's probability is always either equal to the right hand side or greater than the right hand side, but never less than the right hand side. This is the right hand side, and your answer is that this probability of A intersection B can never be less than this particular right hand side. Cool enough? Just a conceptual, very conceptual question. Here it says that if these are your n events, then what is the probability of union of these n events? Let's see. Okay, now when I talk about union, let's take 2. A1 union A2, let's take 2. I know this is equal to probability of A plus probability of B minus probability of A intersection B. That means from the sum, something is being removed. Then the answer is coming out to be equal to probability of A1 union A2. Okay? That means actually this probability is less than or equal to this particular sum. Because from this sum, something is being removed, something is being lessened to get this number. So you are getting probability of A1 union A2 is less than equal to probability of A plus probability of B. If I increase it to 3, again the same scenario holds. This is less than equal to probability of A1, this is A1 and A2, not B. So this is A1, this is A2, this is A1 intersection A2, this is A1, this is A2. So it also gets extended to 3. Similarly, if you have n AIs, basically n events, you get probability of A1 union A2 union A3 up till union AN. Up till union AN is less than or equal to probability of A1 plus probability of A2 plus up till probability of AN. So the thing which is true for 2 is always true for finitely many by mathematical induction. So you can always increase it to 5 to 6 to 7 to any finitely many number of events if it is true for 2. Clear? We have seen it is true for 2 and therefore it is true for 3, 4, 5, 6, any number of events which are finitely many in number. Next question says odds in favor of an event A are 2:1. What is the meaning of this? When I say odds in favor of an event are 2:1, that means probability of A is 2 upon 2 plus 1, which is 3, and odds in favor of A union B are 3:1, that means probability of A union B is 3 upon 3 plus 1, that is 3 upon 4. Consistent with this information, the smallest and largest values for which the probability of event B are given is what? So let's see, what is probability of A union B? It is probability of A plus probability of B minus probability of A intersection B. Now probability of A union B is 3/4, probability of A is 2/3, rest is this. So this becomes 3/4 minus 2/3. What is 3/4 minus 2/3? This is 12, this is 9 minus 8, so this is 1/12. So this minus this gives you 1/12 is equal to probability of B minus probability of A intersection B. Right? So probability of A intersection B is probability of B minus 1/12. Now you know that A intersection B is contained in A, and we have done this, that therefore probability of A intersection B is less than equal to probability of A, right? And obviously it is greater than equal to 0, not a problem, that is always there, it's always a non-negative quantity. Probability of A intersection B is probability of B minus 1/12 is less than equal to probability of event A, which is 2/3, and greater than equal to 0. So probability of B will be actually equal to greater than equal to 1/12 and less than equal to 2/3 plus 1/12. 2/3 plus 1/12, 3 into 4, 2 into 4, 8 plus 1, 9/12, which is 3/4. So probability of B is actually lying between 1/12 and 3/4. So you have this as your correct answer. Pretty nice use of all the algebra operations. Now, next question says that A, B, C are 3 events such that probability of A is given, B is given, C is given, A intersection B, A intersection C, A intersection B intersection C, that is also given. And it is being given that probability of the union of all the 3 is greater than equal to 0.75, then probability of B intersection C satisfies what? Okay, so obviously it's a direct trigger to use probability of A union B union C, which is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. It is given to you that this is greater than equal to 0.75 and you always know that this quantity is less than equal to 1. Probability of anything is greater than equal to 0 and less than equal to 1, but it is given that it is greater than equal to 0.75 and obviously it is less than equal to 1. Now, probability of A is given to you as 0.3 plus probability of B is given to you as 0.4 plus probability of C given to you is 0.8, probability of A intersection B is 0.08, probability of B intersection C is not given to you, probability of A intersection C is given to you as 0.28 and probability of A intersection B intersection C is 0.09. So basically when you resolve this you get 1.23 minus, because this is not known, this is the lone quantity which is not known, and less than equal to 1. So this gives you 0.75 minus 1.23 which is 0.48 minus 0.48 less than equal to minus probability of B intersection C is less than equal to 1 minus 1.23 which is minus 0.23. So clearly what you get is probability of B intersection C is greater than equal to 0.23 less than equal to 0.48. Okay, and that is what is your answer. Fine. So I had to tell that probability of B intersection C satisfies what? It satisfies that it is going to lie between 0.23 and 0.48. Exact value I don't know, but yes, obviously the range is known. So that's how you apply all the concepts of probability in different questions which can be posed like this. So spend some good time with them. That's it from my side. Thank you.